Hi guys, welcome to another session of Bootcamp 2020. Today we will try to cover two topics if we have much time, but we'll start with CDK design patterns. And before starting that, Sarzia, would you like to add anything?
Yes. When I started my career in computer science, basically we were focused on two. Uh, I was basically focused on two topics. One was the programming language, and the other was design patterns. Uh, there's a book called Gang of Four Design Pattern book, which basically covers all the design patterns, 23 design patterns, and they are basically what is a design pattern? Design pattern is not code reuse in the normal sense. For example, you think of it. All the mosques in Pakistan have different designs. But if I ask you, Baris, how do you recognize a building is a mosque?
By the structure of it, it has some domes.
It has some pattern which is
Pattern, yeah.
common. If you think about it, the mosque of Bashai Masjid has four uh, what do you call is complete design of the Bashai Mosque is completely different from design of Faisalabad Masjid in Islamabad. But still, whenever we see a mosque, we recognize it. Whenever we see a church, we recognize it. Therefore, my contention is that they have the same design pattern. They are not exactly the same. It has a basic concept. In the case of mosque, the whole idea was that somebody gets up on top, and when he performs azan, people from distance can hear it. When it started off 1400 years back. Therefore, the point is that what you do is basically take a solution to a problem. So there are a lot of people can hear azan and apply that wherever you have the same problem. But all the solutions are not exactly the same. And when I look at somebody's code, I'm talking about experienced programmers, of course. If I look at somebody's experienced programmer's code and the beauty of that code and the reusability of the code and the flexibility of that code comes from design patterns. So therefore, an average developer even has difficulty in sometimes of understanding the design pattern itself. Vanis is going to today start covering it. The two most important design patterns are composite pattern and the visitor pattern. And what this CDK team has done is done a marvelous job. They have applied these two design patterns. They are not exactly the same. A lot of different frameworks apply this. But the concept is, first I'll tell you the concept of composite pattern. The concept of composite pattern is that you have a part-whole hierarchy. Now, when I first listened to it, I did not even understand what that part-whole means in the first place. What I'm trying to tell you is that, think about it. All of us in this world, humans, are organized around, think about it, there's a whole global community of humans. In the community of humans, there are countries. United Nations is on top. United Nations is on top, and then there are countries which belong to the United Nations. Then there are cities and locales which belong to the countries. So therefore, United Nations is the root. or humanity is the root, whatever you want to call it. Then there are countries. In the countries, there are cities and villages, and on those cities and villages, there are humans. Now, this is a composite design pattern. How? If you think about it, United Nations is a group of people. It does not have any people. Then countries is a group of people. Then city is a group of people. Then village is also a group of people. And the leaf is that person. When you think about the design pattern, this is a composite design pattern where you groups. Now what you want to do is, what is the purpose of the design pattern? You want to tackle either groups or individuals. For example, if you want to vaccinate people, we can have a method in this composite design pattern which says vaccinate. When, let's say, Varis or Huma is a leaf in this composite design pattern, the leaf, if you call the method vaccinate, what does it mean? It means the doctor will come and give you an injection. But when you are telling to a city, vaccinate, all the children and the parents will have the same method, vaccinate. And when you are applying this principle to a group, it means it will iterate and take all its children. So therefore, for example, United States says we call a method of vaccinate in the humanities method. Only one time. We say vaccinate. Now what will happen? Vaccinate, the implementation of vaccinate in the root will be an iteration of all the children, and it will call the vaccinate method of all the children, and so on. In the end, all the groups, cities, humanity, villages are basically not vaccinating anything. They are just calling the children with the same method of vaccinate. And look at the beauty of the design. I'll just call the root and say vaccinate, and all the children will be vaccinated. One after the other, one after the other. Now, this design pattern, which I have just told you, is a composite pattern. But it is what I have just discussed is the object diagram of the thing. In our objects, it is not a class yet. We have not designed actual code. There is an object called humanity. In that object called humanity, there is a city called Karachi or a country called Pakistan. In that country.Pakistan, there is another city, and of course there are other cities as well. Karachi. In Karachi, there is defense society, where I live, and then there is me. If you think about it, these are objects which contain each other. But when you design this is at runtime. But when you design a class, the class will be different. The class diagram will be different. How will be the class diagram? We will, let's say, have a base class which will say group. In that group, we will have the method vaccinate. Maybe it is an interface with no implementation. We will have a group. The child of the group, there will be two children of the group. One will be person, which is the individual, and the other one will be a group which will basically do nothing. The implementation, let me repeat it again. There is a class called group, And in that class called group, we have children. One is country, one is city, one is village. All of them extend the main group. Now, the surprising thing is there is a fourth class also, which is individual or a person class. The surprising thing is the person class also extends the group. There's group class, there's country class, there's city class, there's village class, there's person class. All these four classes extend the group class. What? How is it helpful? Any method which is in the group class, in the group there is no implementation of vaccinate. It says it's an abstract method. And all these four classes will have different implementations. The country will iterate over the cities. The individual will actually get vaccinated. Now, this is the class diagram. Then, previously, what I told you was the object diagram. So, this way, of course, it takes a while for you to comprehend the advantages of composite pattern. Now, there's a problem. If we add the method vaccinate in the main group, this is very good if we are sure that this software is only going to be used to vaccinate people. There's a hunger problem all around the world also. Let's say we want to have a method vaccinate and we also want to have a method feed, eat. If we want to have a method called vaccinate and if we want to add a method eat, then whole hierarchy will have to add a method eat. Because we want the interface of all the classes to be the same. And we want to perform operation on the root and everything, it applies to everyone. Therefore, all the classes will have to implement eat also now. And if we go on increasing the methods and functionality, the problem will be that these classes will remain forever dynamic and unstable. So therefore, there is another method. Why don't we take the functionality of vaccinating out of this composite pattern and we introduce a visitor pattern? Visitor pattern is much tougher to understand, but for now you just understand this, that basically you have a stable methods of visit in all the hierarchy, and in the visit you pass it the node itself. And whenever, for example, we will see in the tagging library, which has been, what do you call, tagging, how do we tag a resource in CDK? So therefore, we have created another tagging library, which is a visitor pattern. But let's first understand the composite pattern. Varis will tell you about the composite pattern, and then we will slowly move forward. Varis, please take over.
Okay, thank you so much, sir. So that was a very detailed explanation about the CDK patterns. So let me share my screen.
CDK has implemented both the composite pattern and the visitor pattern to make the code beautiful.
Yeah. So I actually made a few slides for the introduction, but Sajid has given us a very nice introduction. I think he has given a better introduction than I could. So let me just move on. How does CDK actually implements these patterns in their in our application? So let me just okay. So most of the stuff that we will see today, I have already covered it in the previous steps, but I've covered it in bits and pieces in different lectures. So we thought it would be a good idea to actually make it a new step, make a new step for CDK constructs and patterns, so that everything can be recorded in a single recording. Now, I've actually discussed this diagram in quite a few lectures, but let me just revise it because you need to understand it to understand how does CDK implements composite design patterns. So the first thing that when you look at this diagram, the first thing you realize is that it is a hierarchical tree structure. So it is a tree structure. You can see it forms kind of a tree, and it also has some hierarchy to it. So like Sarji said, we have people on top, then you have countries, cities, and so on. So in a CDK structure, that your root node is always app. So in a composite pattern structure, you always have just one root node. You cannot have more than one root node. And in the CDK project, that root node is your app, and it cannot be anything else in your CDK project. So this is the first important thing that you need to understand, that your root node would always be the app, the top level node. And at the bottom at the bottom of the tree, that is the leaf nodes that Sergio talked about. In his example, they were people. In this example, it would always be L1 constructs, or mostly be L1 constructs. So the top level the root would always be the app, and the leaf nodes would mostly be the L1 constructs. Now this is the first important thing that you need to understand. The second important thing that you need to understand from this diagram is that every node needs to be created within the scope of its parent node. So as Sergio said, we have, let's say this is countries, and then in that country we have cities, and in cities we can have suburbs and so on. So likewise in the CDK project we have app. In the scope of the app we have stack. So if this was a country like Pakistan, then in the scope of the Pakistan we would have many cities. But in the CDK project, in the scope of the app, we have stack. Now you can have more than one stacks in your CDK project, but that is for like a very complex project. But usually we just have one stack. But you cannot have more than one app. You cannot have more than one root node. So stack over here is created within the scope of the app, and these L2 constructs are created within the scope of the stack. So this is how the hierarchy is. So stack is the child of app, and L2 constructs are the children of stack and grandchildren of app. So everything is present in the scope of the app. This is how your CDK project is structured. So this is the second important point that you need to understand. The third point is that we usually work in this area. This is already created for you when you write the CDK init command. But this is where we start working within the scope of the stack. And we usually write L2 construct. Like if you want to make a lambda, we usually write L2 construct of lambda because it is much easier to write. It's shorter code. It's a shorter code. But what we don't realize is that L2 constructs would always break down into L1 construct when the CDK is creating the CloudFormation file. Because L2 construct doesn't mean anything to the CloudFormation file. It only looks for L1 constructs. And every L2 construct that you write has to break down eventually into L1 construct. So what you don't realize is that when you make a lambda function, when you normally write a lambda function in L2 construct, you're actually creating few L1 constructs. So from what I remember, you create a L1 construct of lambda CFN, like a lambda function, L1 construct of lambda function, and you're also creating a role when you're creating L2 construct of a lambda function. So when you create L2 construct of lambda function, you create a CFN lambda function, and you also create a role for it, and then that role gets assigned to this lambda function. So this is what is happening behind the scenes that we don't realize.
I'd just like to add, this is our object diagram.
Yeah.
All these things are at runtime. This is not a class diagram. We'll discuss the class diagram separately. But this is our object diagram. App has stack has L2 constructs, and L2 constructs have L1 constructs. Of course, we can also have L3 constructs after stack, and which can contain L2 constructs and so on. But this is an object diagram which app is a parent of stack. Stack is a parent of these three L2 constructs. And L1 constructs are the children of L2 constructs. Yes, please.
Yeah, yeah, yeah. So you can also have L3 constructs over here, but then they will break down into L2 constructs and then L1 constructs. You can also have your custom constructs over here, which then gets broken down further. Now, the fourth point that you need to understand is that in this diagram you have two kinds of nodes. One is the composite node. A composite node, why? Because it has a child. Stack is also a composite node because it has some children. L2 construct is also a composite node. This is also a composite node. But a node that doesn't have any children is a leaf node that Sergio talked about. That was people in his example. So in this case, it would mostly be the L1 construct. So you can see L1 construct doesn't have any children. So this is the hierarchy of your CDK project. Now, you need to understand that every construct that we saw over here implements a class called iConstruct, and this is what tells the CDK project that this is a construct. Not only the construct, but also the stack. Every node over here you see implements this class iConstruct, and this actually makes it a construct. And when you when this class is implemented in the construct, it actually gives it some properties, and one of the property is the node property that actually allows us to access the relationships between its parents and children. So uh, if I talk about this construct over here, if I can uh, from the node property of this construct, because it is implementing iConstruct class, I can find out the relationship it has between the stack with the stack and with the element constructs. So this can be a very useful tool to find the relationships between the parents and children. So now I'm going to move towards the code.
Paris, you will have to increase the resolution.
Yeah, sure. Now, now I've also covered this before that whenever you create your project using CDK init command, it automatically creates a bin folder for you, and in that bin folder you have a file, and in that file it automatically creates an app for you that is the root node of your tree, the app, and it also creates the stack for you, the instance of the stack for you within the scope of this app. So your stack goes in the scope of the app, and it also creates a lib folder for you where exists the class for this stack, and this is where we normally write our code over here. And this is where we normally start writing our code. Yeah, right now it's empty. I've commented out everything from the step. Now, the first thing that I want to show you is how to actually find the relation, how to actually find that who is the parent of this node over here. So right now we are in the scope of the stack. We're working in the scope of the stack. Now, if I actually want to confirm that whether the app is the parent of this stack or not. Now, to do that, I told you that every class, every construct or every stack implements iConstruct class. And this gives it a property called node that allows us to actually find the relationships it has with its parents and children. So what I can do is I can console log this. By this I mean the scope of the stack dot node. So I told you it gives it a property called node, and that property allows us to find out relationships between its parents and children. So if you want to find parents of a particular node in a CDK project, you write scope. So this actually tells us that in which scope is this construct made, and we know that this construct was made in the scope of app. So it should return app. Now to run it, you can just write CDK synth. You don't have to deploy it, because when you write CDK synth, it creates a CloudFormation file for you. So you can see it gave me some information. So this is the information about the scope, but the name of the scope is app. It is returning, it is saying, let me just zoom it in. It's saying that the scope of your stack is app. It has just confirmed us. So this is how you check the parent of your node in a CDK project. Now what I can do is I can actually remove this and let's create, let me uncomment this Lambda function. So this is where I'm creating a Lambda function using L2 construct. So this is a very simple Lambda function. In the code, I'm using inline code that allows us to code using string. And then in the handler, if you use this inline code, you have to write index in the handler. So this is just a L2 Lambda function. So if I can just move everything over here. So this is L2 Lambda right now. Now we have a stack in which we created a L2 Lambda function, L2 construct Lambda function. But now because it is a L2 construct, I already told you that it should also create some L1 constructs behind the scene. We don't get to know about it, but we'll see that how can we see details about these L1 constructs. So now this is the structure that we have right now in our stack. Now what I want to do is I actually want to find out that whether I actually created this Lambda function within the scope of my stack. Well, I know that I did because I wrote this over here, but let me just confirm it. To actually confirm it, you can actually again use the same thing, .node .scope. So this will give me the immediate parent of my Lambda function, which should be this stack. So again, I'm going to run CDK synth. So you can see it gave me the scope of my Lambda function. That is my stack. This is the name of my stack, parent stack. This is just the information about the scope. You don't have to worry about it right now. Now there's another function here as well. Sorry, not function, a property called scopes. Now this doesn't only give you the scope. This doesn't only give you the information about the immediate parent, but it gives you two or more scopes. The first scope is your scope in which you're running this command. That would be, in this case, would be the scope of this Lambda function. So it will give you this scope, the scope of your immediate parent, and scope of any grandparent or grandparent or anything above that. So it will give you scope of this thing, scope of the immediate parent, and scope of the grandparent, grandparent, and so on. No matter how many nodes are above that, it will give you scopes of everything. So let's try to run this. We should get 3 scopes in this in the output. 1 scope, 2 scope, and 3 scope. So you can see the first scope is the grandparent, that is the app. The second scope is the stack scope, that is this one. So it gave us scope of this, and it should also give us return the scope of the Lambda function, and that is over here. So it returned us 3 scopes. So this is also a very useful property that shows us all these scopes that are involved with this construct. Now I'm actually happy. I'm happy. I'm satisfied that this is the child of stack. But you can also verify it other way around. So if I write this .node .children, what I'm doing over here is that I'm saying that I want a list of all the children of the stack. And right now we only have one child, that is L2 Lambda construct. So let's see what other return. Now I'm just verifying the other way around from the perspective of the parent of the stack. So you can see it gave me just one output, and that's it. It's saying you just have one child, that is function. Now there's also another way of finding the child. If you have like many different children in your stack, you can And if you're just looking for one particular child, you can actually pass in the ID of the child in this function, node.find child, and over here you pass this ID that you give to the construct when you're making it. Pass it over here. So if it cannot find this a child with this ID, then it's going to give an error. But if it can find it, then it's going to return me this construct. You can see it returned me the function with this ID. So I'm now satisfied that this is the parent of this Lambda function and this is the child of this Lambda function of this stack. Now what I want to do is I can also peek inside my Lambda function. Now I told you that this is an L2 construct and it may have 2 or 3 or more L1 construct, or it might also have some L2 constructs inside it. I'm not exactly sure. Let's see what's inside it. So to check that, just like this. So I can also find one child inside it, but now I'm interested to have a look at all the children that Lambda function has. So Lambda function dot node dot children. So this is not a function, it just gives you a list of all the children it has. So the first child, the first child is not a L1 construct, it's an L2 construct. It's an L2 construct of role. And how do I know it's an L2 construct? Because it doesn't have a CFN prefix. So this means that our diagram is wrong. There would be an L2 construct over here for role, and then it would have some more L1 constructs down below. So you can see how many things L2 construct for Lambda function does for us. So this is the first child of it. Okay, the second child is the L1 construct of Lambda function. So it creates an L2 construct of role for us, and it also creates L1 construct of Lambda function for us. And let's see if there's anything else. No, there's nothing else. So this is what is happening behind the scenes. Okay, so let's remove this now. Okay, so another thing that you need to know is that, as I told you before, that every construct implements I construct. But right now the type of this is lambda.function. Because it is implementing I construct, I can also change it to I construct. Doesn't matter because it's implementing that abstract class. So let's leave it for now. Now what I can do is I've actually made a custom construct. I've actually made a new folder in the root directory, and in that I've made a custom construct. And in my custom construct, I just have another lambda function. So now we have something like this, and we would have more L1 constructs down below. So now we have 2 children in our stack. And we can verify that again. This dot node dot children also return us 2 children. What's important to understand is that one lambda function is directly within the stack. The other lambda function is not the immediate child of stack. It is present in the scope of the stack, but it's not immediate child, it's the grandchild. The immediate children are only these 2. So you can see the first one is the function. The second one should be our custom construct. And this is the second one. Okay. So this is how we actually verify the relationships between the relationships your node has with your parent and children. Now let's say what else do we have? Okay. Now this was your what do you call it? A composite design patterns in which you have a hierarchy of tree. Now what I'll show you is how does CDK implements visitor pattern. Now let's say that so basically visitor pattern actually allows you to go to a particular node in your composite tree, in your composite tree diagram, and it says that within the scope of that node I can loop over all the children it has, and not only the immediate children, but also the grandchildren. So if I run a visitor pattern on this node of the tree, what it will do is it will say that I can loop through all the children it has. So it will first go over here, it will go over here, over here, over here, over here, everywhere. Not in this particular order, but it will loop through all the children of this particular node. This is how CDK implements the visitor pattern. So you would usually use visitor pattern after you have created the tree, and if you want to change something, uh, and if you want to change a few or more constructs within the scope of a particular node, then you would use visitor pattern on that node. So let's say if I've already made this application, and in the end I say, okay, I want to loop through all the Lambda functions that I have in my application, and I want to console log something for it, or I don't know, I'd do something with them. So I can do that using visitor pattern, because the visitor pattern actually allows me to go to a particular node in the tree and then loop through all the children it has, and then you can do different things with them. Let me show you how. Okay. Okay. So now to do that, CDK gives us an aspect class. Let me show you. Now to run a visitor pattern on your tree, CDK gives us an aspects class. So to use it, you write CDK dot aspects dot off, and this is where you give the scope on which you want to run the visitor pattern. So if I give over here, if I give this, so this means the scope of the stack. So I'm saying run the visitor pattern over here. So what it will do is that it will actually loop through all its children. So it will go through this, and we can change anything in any of these constructs in that loop. Like it's a loop, you can do anything with these constructs. You would be receiving these constructs within in the loop, and then you pass the scope where you want to run the visitor pattern. I can also run it over here, or even on the root node. It doesn't really matter in this case if you run over here or here, unless and until you have to make changes in the stack. I'm only interested in changing these things over here, so I'm just going to run it on my stack. So I'm passing the scope this, and then you write add, and in the add you have to pass a class that I've made over here, and this class should implement an abstract class provided by CDK called iAspect. And because it's an abstract class, it also has an abstract function that you need to implement over here. So for now, we have left the constructor empty. And this function that we need to implement because of this abstract class is the visit function. And what this function does is that it runs for each and every value in the loop. So if I'm running my visitor pattern over here, it will loop through each and every construct. And this function over here, the visit function over here, would run for each and every of these constructs. And I can do whatever I want to in this function, in the visit function. So right now what I'm doing is that I'm saying that if the node or the construct that I'm getting over here, if it is of type lambda.function, then log this. Or I can also like add a layer to my lambda function, or I don't know, add roles or I can do anything with them. So this is what I'm doing over here. Let me repeat this. Now this function actually takes a class which has implemented CDK iAspect. And because this is an abstract class, you also have to implement this function. Otherwise, you would get an error. Like if I remove this, it should give me an error. Yeah. This function actually runs for each and every child on which you ran the visitor pattern.
Basically,
and over here
the
I'm
visit will be called for each node.
yeah, yeah. Visit will be called for each node of this, which are defined within the scope of this stack.
Yes.
Yeah, yeah. And I'm just logging something over here. I can also check for other things, but I don't have any other kind of resources over here. I only have two Lambda functions. So let's see what happens. Now it will not only find this Lambda function, but it will also find this Lambda function, which is not an immediate child, but it is a grandchild of it. So let's see. So if I now run this parent CDK synth, it should print 2 times because we have two Lambda functions. Mm. So you can see it printed found a function 2 times because we have two Lambda functions. One is the direct child and one is the grandchild. Okay, so this is you will usually use this if you want to do if you want to add a custom logic in the visit function. But AWS also gives us a built-in function that actually uses this concept of aspects, which is this function. So this function uses aspects, but it can be only used to tag your resources. So it works very similarly to this. You can see the code is also quite similar. So cdk.tags.off. In the off, you will give the scope of the node. So again, I'm passing this over here. So it's what it will do is it will loop through all the nodes within the scope of this stack, and it will add a tag on each and every node. And what is that tag that you give over here? So it's a key value pair. This is the key of the tag, and this is the value. So basically, it will add a tag to this, everything within the scope of the stack. If I had ran it over here, then it would have also added a tag to the stack.
I'd like
So
to
this
add
is like
something, Varis. The first time, of course, the answer is obvious, but the first time I was doing it, I ran this tag. And what happened was that I checked the cloud formation file.
okay.
In that cloud formation file, only the leaves show up, and
Oh,
only
okay.
those were tagged. At the runtime in memory, the stack will have a tag, the L2 lambda will have a tag. But in actuality, what goes into the cloud formation file are only L1 constructs.
Yep.
L2 constructs, from the perspective of cloud formation, is just a figment of imagination. Now only L1 constructs appear in the cloud formation thing, because only L1 constructs are understood by cloud formation. So therefore, when you run the synth CDK synth, only the leaves will appear in the lambda function, in the cloud formation file, and those tags will be shown. The parent and the L2 constructs and the L3 constructs don't show up in the cloud formation.
Yeah. So that is also important to understand that in the cloud formation, you only have L1 constructs. So basically, when you're running the tags over here, that function of tags over here, you're actually saying that leaves, that the determination of the leaves, all the L1 constructs that end up after the stack would need to have that tag involved.
Basically, all the L2 and L3 constructs are nothing but organization units.
Yeah. Okay. So moving on. So these are the two. So this is how you can add tags very easily, and this is how you can add some custom logic using visitor pattern. Now you also have annotations. So annotations are basically just extra information implement the visitor pattern, you can only add annotations to a particular scope, and that's it. Like if I pass this over here, it will only add annotations to my stack and not the children. So we have three types of annotations. Let's start with the first one, that is info. We add info. So this appears in white color when you try to deploy or synthesize your CloudFormation file, and you can just like pass some information that you want to show to the user, like hello world. These can be useful when you want to show someone like a warning or a error or some information using at build time. So you can see it also tells you that where did the information came from. So it's saying it came from the stack. Why? Because I passed the scope of my stack over here, and it's saying hello world. Now this is just normal information. You can also add warning, which will show up in a bit more bright color. That is yellow, I think. Let's see. This is to warn the user that there might be something wrong in his code. So you can see it showed up in a yellow color. And there's a third type as well called error. So this will actually break your if this line is present in your code, it will actually not synthesize it. It will break it. So you can see it has found errors. So you have actually, this is the way of inducing an error in your stack. So this is how you can add some annotations. Now, one thing is left. That is how you can actually add some context information at build time. And you've also been provided with some documentation. So it says that context values are made available to AWS CDK, and there's like 6 different ways of doing it. And you can actually go through this document. All of them are quite easy, but I'll just show you one way that is, I think, the best way to do it, that they are discussing over here, to make a CDK context.json file. So you can actually make a CDK.context.json file, make sure the name is same. You can make this file in your root directory, and in this file you can pass whatever you want to, whatever your context is. So over here I'm saying I want to pass a token in my context, and the value of the token is this. So, and then in your stack you can retrieve that context using this scope, or in this case this dot node dot try get context. And what kind of context? What value in the context? What key in the context? I only have tokens, so I'm just going to write token over here, and then I'm logging it. So let's see. I'm not sure if this should be. Let's see if it works or not. So I'm not sure what this scope means over here. So Sajia, do you know what does it mean over here?
Let's find out. I don't remember exactly.
Okay. So it did return me my value from the context.
Because it should return from anywhere in the tree.
Okay. Okay, that makes sense. So it doesn't really matter whatever scope you put over here, it should return it. Yeah. So this is how you can get the context at build time. And I think this is it as far as coding is concerned. Yeah. So, sir, would you like to add anything to it?
But what we are going to do is basically just we have covered the basics of the whole how CDK has been organized. We can go in detail, much detail, even more than that. But at the first stage, when the students are just beginning, going into too much detail also creates misconceptions. And we have hinted that there is a whole, you can play with this CDK and basically customize it. Varis is already, and his team is already customizing it on a product. Just let me, we are going to finish off this today. We are not going to start with the next topic. I'll just tell you where we are going from here. Where we are going from here is that we are going to basically now teach two kind of databases. One are the relational databases. AWS has been very successful in creating a SQL database, Aurora Serverless, which is unlimited scalable. Version 2 has arrived, which is right now being beta tested. And right now, I want to teach my students this thing that either use Aurora Serverless or a graph database. Because if you have a very simplistic need of data storing, then DynamoDB or MongoDB will also be okay. But for sophisticated applications, either use, depending on the use case, either use a relational database, which is tried and tested. And recently, the last few years, graph data has also arisen. So therefore, the products, AWS is giving us Aurora Serverless. And for serverless connection, they have also given the data API. Huma is going to cover that next week, next class, serverless databases and Aurora Serverless. And then the data API, to how to call in a Lambda function. You need if we have a session, the problem with session is it takes too long and to connect, and each Lambda reconnects. So therefore, we want the data API as well for Aurora Serverless. Huma is going to cover that, and Varis are going to cover that next class. In the next few classes, we are also going to cover Neptune, which is a graph database, and how it is. Graph database are very compatible with GraphQL queries as well, because there's a difference. Graph database is a storage database, and GraphQL is an API specification. So therefore, we are going to learn it. We are not going to cover every step going forward. We are going to pick and choose and complete this CDK learning. Then we are going to go, which all of you are going to get very excited, go over Android and iPhone development. We are going to use three technologies for Android and iPhone development. We have done web development. We have done cloud development. And in the end, we are going to do Android and iPhone development using React Native, using Expo, and using Amplify. These three technologies together, we will learn to develop, and you will be amazed how quickly you could develop an Android or an iPhone application in the same code base and deploy it for the customer in a very short order, maybe a few weeks. So therefore, because the thing is, most of the customers have moved over to the mobile. Mobile web is a reality, but mobile apps are also a reality. And I want my teachers as well as students to know mobile application development, and they feel comfortable in developing Android and iPhone development apps. And using the same technology. We are going to use the same React concepts, which we have already learned. The new things, Amplify, we have already covered a little bit. And Expo is a new library. And we are going to cover that. And we are going to finish out with some theory this bootcamp. Then we will take a rest for a few weeks. And then we will start Bootcamp 2021, which will cover AI, artificial intelligence, because that's how to develop AI APIs, how to develop voice interfaces, and so on. But that's another bootcamp. We are going to finish up this bootcamp in a few months, and hopefully Huma and Varis will be on the island of Bora Bora, and all the students enjoying their vacation after we completed this. It has been more than a year. But the good thing is, both Huma and Varis started off as students and have become teachers, and In the end, the idea is they become gurus and not only build their own lives, but their family lives, as well as make our country strong and do something for humanity as well. So therefore, that is the whole objective. Has been a long journey. A lot of people have become very tired, but a good developer never gets tired. Because when you are debugging, Waris, sometimes you
Yeah.
think about killing yourself and you are extremely tired. But a developer never gets tired. Actually, it's not just a question of software developers. If you look at a woodcutter, anything which humanity has done, look at a painter. Sometimes I send Egyptians work of art on my software development page. If you are not a lover of what you are doing, if you don't love painting, you should not paint. Because there's no way you will be able to paint. You will get tired, you will get frustrated. We are special kind of people who want to create things for humanity. Of course, we get paid for it, but everybody has to eat also. But that is not the main objective. If somebody told me to do a bad job and said, I will give you only 10 rupees, please, $10, and please do it. I don't want a very sophisticated thing. I can't do it because my name will be on it. You cannot ask a painter to draw a bad painting. He will never do it. He or she will never do it. No matter how much or how less you pay. We are artists and we want to change the world and we want to build things. So therefore, what we built, for example, this bootcamp, when 50 years from now, that is my imagination. These videos will be still around, helping people. Maybe the technology would have changed, but maybe the people can appreciate how much effort we put into it. And it is a teamwork. A lot of other people who were not behind the camera have built this repository. And it's a teamwork, about 20, 25 people. And other new classes will also come in and build new things and new learning material for it. Thank you, everybody. And we will see you in the next class, start relational databases. And we will also, Varis will also cover a little bit theory of relational database. Zeeshan will be also by that time joining back. He's studying a little bit and he will be joining us from next class or the next class. Let's see how tired he is. And we will go from there. Thank you so much, everybody. Bye-bye.
Bye-bye.